Okay, so this is the video between 26 and 30. Let's read number 26. The average blue whale gain weight at constant rate each day during the first 6 months of life. The relation between the average whale weight in ton, W, and its age in day, D, for the first 6 months of life can be modeled by the function W equal 0.1 D plus 3. Based on this relationship, which statement it's not true for the average blue whale. So even before we start solving, before we start just doing our math, let's highlight what they want from us and what's this problem about. So always just remember to highlight the most important information. So the most important information, I see a linear equation. Again, W represent the weight in ton, D represent the number of the day, and this equation represent the weight versus day for the first 6 months. So we know our linear equation always y equal, okay, let me try the pen sometime. Okay, so always the linear equation y equal mx plus b. We know b, it's the starting, it's the initial value, whatever. M, it's your rate. So this is the rate, and always this is your starting value, your initial value. So in this case, let's talk about the weight. So we can say at birth, that's the initial weight. So we know this is the initial weight. The initial weight, it's 3. And then each day, the whale gain 0.01 ton. So we know how to read this equation. Now, the main thing, let's find the statement which is false. Not true means false statement. We're looking for false statement. Now, let's read F. The average blue whale weighed 3 tons at birth. At birth. This is correct. 3, it's the starting point. The starting means at 0 day, means at birth, yes, weighed 3 tons. So this is true. Since this is true, we're gonna cross it. We're looking for the false statement. When the average blue whale, it's 5-day old, it weighed 20 tons. Let's see. So the weight, it's 0.1, so 0.1 times the number of days, T, plus 3. They told you at 5 days. So let's do this equation. So we will see at 5 days how much this whale weight. So again, we're going to use our calculator. So kind of calculate mode. So there, enter. So we're going to look for the weight. So 0, 1 time 5 plus 3. You see, I'm plugging the equation, this equation, to find the weight. Enter. So this well should weigh 3.5 tons in 5 days, not 20 tons. So this statement is false. So the first statement true, the second statement is false. So we know this is the answer. But let's see the other, if they make sense or not. The average blue whale gain 0.1 ton per day during the first 6 months. Yes, 0.1 per day. That's the rate. 0.1 per day. So this is true. When the average blue whale weight 18 ton, it is 150 days old. Let's see. So we do 0 point time 150 days plus 3. If you plug this in the calculator, it should be 18. So let's see. 0.1 times 150 plus 3. Enter. 18. So we know this statement is true. So the answer would be G. That's the false statement. And be careful with not true. Number 27. Quadratic function G and K. So we have G and K are shown below. What value of C would be the graph of K 9 unit above the graph of G? So in this case, this is what I tell my student. Please use the graphing paper. If you forget how to do this, please using the graphing paper. So always in the start, you're gonna have a graphing paper, use it. So let me grab my graphing paper from my smart board. Okay, I typed it wrong. Okay, so graph. I want to show you how to use the graphing paper. So it's one we're gonna put on the top right here. Okay, so in this case, okay, so in this case, we're gonna minimize the graph. So I want you to see it. So we have two functions. The first one, it's 5x squared minus 12. So guess what? We know that the negative 12, it's your C, your constant. That's the y-intercept. So the first graph, G, will have a y-intercept of negative 12. I'm going to change this scale. This is large scale. I'm going to change it. So imagine this is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the first parabola gonna cross at there. Of course, it's open up because A, it's positive, so we know it's gonna be open up. So this is little portion of G. So this is G of X. Now, for what value of C will be K 9 unit above G? 9 unit above G. What means 9 unit above G? Means you go up 9 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, this is how K gonna look like, gonna pass through there. So what value of C K should have? What's the constant? Should be. What's the y-intercept here? We know the y-intercept, it's negative 3. So C should equal to negative 3. That's the answer. C should be equal to negative 3. Use the graphing paper if you have any question about transformation and you don't see it. Now, 28. A customer pay an annual member fee of $85 at a neighborhood car wash. So he washed his car, he pay every year $85. Each time he take his car to the car wash, he pay $7, only $7. The total amount of money he spent at the car wash in 1 year in dollar can be found using the function. So this is the function. Again, when we see this type of function, we know this is a linear. What means linear? Y equal mx plus b. B standing for the constant, standing for the starting fee, the starting point, and M standing for rate. We're dealing with the real life situation. So what does the variable X represent in this case? So let's talk about the charge. They charge him 85 annual member fee. So when he start, that's how much they charge him when he start. So how about if we want to write an equation? This is the equation. 85, it's the starting point. And $7 each time he show up. That's how much he pays, $7 each time. So what's X represent? The 7 is the rate of X. So X could be what? X, I know now. This is simple. X should be the number of time that he watched his car. So let's see which statement match our conclusion. The total amount of money the customer spend each year. Nope, it's not. X cannot be the total amount of money. The total amount of money, it's Y. It's not X, it's Y. The number of months the customer has been member. Nope, it's not the number of months. The number of time the customer take his car to the car wash in 1 year. Yep, that's for sure. The cost each time the customer. Nope, the cost it's $7. So this is simple question. So the answer would be H. The owner of the store buy large boxes of candy bar from warehouse at repackage them to sell them in smaller boxes in his store. Sorry. The store owner package 4 candy bar in each small boxes. Each large box contains 24 candy bar. Which graph represents the relation between X large boxes and Y small boxes? So let's see. So what do we have? We have this man, he buy large boxes. So this is the large boxes of candy. Of course, the large box, he has a lot of candy. And what he does, he sell them in small boxes. Small boxes. Of course, they said X represent the large box, Y represent the large box. So let's see. The large box contain how many candy? 24. 24. I want to do the same color right here. The large box contain 24. 24 chocolate bar or candy, whatever you call it. And the small boxes contain right here 4 candy. So how many small boxes can you make using a large box? One large box. So 24 divided by 4, how many? 6. So you see, one large box will give you 6 small candy. We know that relation. Okay. So one large box. So you see, one large box. If you do table, you do X and Y. Of course, X is the large box, Y it's the small box. If you bought one large box of 24 candy, how many small boxes are you gonna make? You know, you have 24 divide 4, you're gonna make 6 small boxes. If you bought 2 large boxes, how many small boxes are you gonna make? 12. Kind of, you're gonna double it, because 2 large boxes, you're gonna have 48. 48 divided 4, that's 12. So this is the relation between large boxes and small boxes. Let's see which graph gonna represent it. So here I see 1 and 4. This is wrong. I'm gonna cross it. So we're gonna cross, let's see. We're gonna cross C. Now 4 and 1, no, for sure no. How about 1 and the number between 4? Okay, how about 2 and 12? This is good. How about 3? How about 4 and 24? This is good. So how about this one? This one at 12 you have 2. No, no way. You cancel this one. So you can cross B, you can cross D. The answer is A here. We know. Using what? Using this table. You can use this table, but also use a visual representation so you can see. Now, the function L equal 0.8 t squared model the relationship between L, the length in feet of pendulum, and T, the period in second of pendulum. Which value is closest to the period in second for the pendulum that is 30 feet long? Again, when they give you equation like this, you know you're dealing with a quadratic equation. Now, what's the question? The question, they give you one variable. They give you the period. I mean, they give you the length and they ask for the time. So they ask for the time. If the length is 30 feet long. So what you're going to do in this situation? In this situation, you're going to replace L by the length by 30. That's your length. And you have to find T. Now, this is what I tell my student. If you can set your quadratic equation, you can solve it using the calculator. I will show you how. But first, your equation must be equal to 0. So subtract 30, subtract 30. So the equation you're going to solve, it's point t squared minus 30 equal to 0. When your equation is set to 0, guess what? You can solve it using the poly roots. So this is what you do. Poly, poly roots with an S. Then you open parentheses. You type your equation as you see it without 0. You type this equation without 0. And then you put your variable, which t. So the equation is 0.8 t squared minus 30. Then you put comma. We're solving for what? T. Comma t, enter. We have two values. The first value is negative 6.12. The second value is 6.12 second. Now you're going to choose one. And now, since we're dealing with real life, the time cannot be negative. So you're going to cross the negative time. In this case, you're going to choose only the positive time. 6.12 second. 6.12 second is J. Now after this video, we're going to do number 31 to 35. I hope you enjoyed the video.